we're going to go ahead and take a look at writing two sample t-tests. This means we're going to be comparing the mean values of two different groups, right? And we have two samples, one sample from one group and a sample from a different group, and then we want to compare them depending upon what's being asked. So here are two examples of hypothesis tests for a situation here. We're comparing test scores of students who were in class, or called proctored when someone's watching them, versus online students. And so you will see, we wish to see if there's a difference in scores. So if you look at that right there, right, we wish to see if there's a difference in scores between the two groups. The null hypothesis, again, no difference. That's again what the definition of null is. You'll see we're saying the difference between those two equals 0, which means there is no difference. You may also see it or write it as mu1 equals mu2. The alternative is that there is a difference, okay, that there is a difference between them, meaning that when you subtract the two values, their mean values, there will be a difference between the groups, meaning that it's not equal to 0, or you may see it this way, okay? And then another way that we're looking is mean scores proctored test is lower than the mean score of unproctored tests. And so you will see here the mean score of proctored tests is lower. Proctor's is 1, the first group. So if proctored scores is lower than 1, you can then say the mean. Of course, the null hypothesis is equal to 0, no difference in here. mu1 minus mu2 is less than 0, meaning that there is a difference between them, and it's negative because the proctored test is lower. And the idea, of course, is that online students somehow are going to cheat or do something different than proctored, or proctored students are more nervous. There's some reason that would be the claim. You could also write it this way, where mean1 equals mean2, or mean1 is less than mean2. Okay, some of you may be asking, what if I wrote it the other way? Now it depends. I could have technically done it this way for the alternative. I could have said mean2 is greater than mean1. We would get the same results. We could have done it this way. That could have been done. And then when you run the test, you change the inequality symbols. But notice we would end up changing the direction because we were saying that it's greater than, and so that's how we would have done it. You could have done it this too. This would have been okay. Okay, in terms of our work here, could have done that way. Let's go ahead and take a look though at actually running the hypothesis test in this situation. Now that we're given the sample data here, there's the sample data. There's two samples, right? The proctored and unproctored. We have all the information. The evidence looks like that maybe non-proctored, right, scores higher, meaning the online kind of group of students, versus proctored. The evidence does, but again, this is just a sample. And so if we did another sample, we more than likely would not get the same results. And so here is our null and alternative hypothesis, okay? H0, HA. You'll see we're saying that the non-proctored is, the null hypothesis is that it's equal to 0. And notice in this case, I'm using the alternative notation, right? That the mean proctor is significantly higher, and because of that wording, I'm writing it this way, okay? It's greater than 0. And then, of course, this is two sample tests. For this case, we're going to assume the conditions are met. We do that in example 2, the IRL. Number 4, this is where we have to calculate a test statistic and p-value. So we're going to end up using technology to do that. This is a two-sample t-test. Okay, so this is where on StatCrunch you would say t-stats two-sample with summary data. And so you're going to go ahead and we got to put in the data we have. So for the first group, I'm going to use the non-proctored because we're saying that one's greater. So 74.26 and 18.5, 74.26, 18.5, sample size, I'll get that again. The next one was 70.29 and 22.09, 70.29 and 22.09. Let's make sure we're good. Okay, you want to make sure you enter that data in correctly. And then this is 30 and 32. That's all we need to do. And then we're checking to see that it's greater than, let's double check sample size, 30 and 32. Non-proctored is 32. So this is 32 here. This is 30. And that's it. And we have this correct. It's a hypothesis test. We're not doing confidence interval, compute. And this is where you go ahead and get your test statistic right here and your p-value. This is your test statistic. And so that's where I got those numbers from. 0.764. Let's double check my numbers here. This test statistic based off of that data. Let's make sure we entered everything correctly. Edit 7426. This is what you always got to do. 7426, 1815 for 32. Perfect. And then you had we had 7929 and 2209 for 30. So okay, so the test statistic is a little different. It is, what do we get? 0.224 and 0.765. That's what I get. Again, we need to, so 0.765, and this is actually 0.224 there. So we would have that there. And since the p-value is greater than alpha, we fail to reject. Since the p-value is greater than alpha, we fail to reject. What that means then is that we're saying this is true and we're rejecting that there. That's what we're doing there. And then there is sufficient evidence to show that the non-proctored, there's not enough evidence to show that the non-proctored score higher than the proctored students.